Okay, yeah. This is the first time I actually got this out quickly. Wow. I'm improving. Alright, I'm just gonna wait a bit. See if anybody comes in. Gonna be a short one today. Gotta just go for an hour today. Got not doing the best right now. Got a terrible thing on my tongue. Bit it real hard in the middle of the night. Not gonna be fun talking. May end earlier than now that I just described me doing. Alright, I think we've already done this. Have we? Pilot. Yep. Yeah, we've already done that. I don't know if we did the quiz. Let's see. Point. What is this? Does this compile? Okay, we got immutable A as a point. That's an I32. A dot x plus equals 1. Yeah, that's fine. That's mutable. At B equal a new point. Yep, A dot x plus equals 1. Print BX. Oh, yeah. So, we'll just compile that. And everything else is directly pointed there. Let's see why it won't. Yeah, that'll compile. B.x, I believe that's implementing the copy. So, since that implements the copy trait, I believe that means that this will in fact compile A, and B, I also believe that will output 2, 3. I'll output 3, perhaps. Let's gonna quickly do this. Looks like there's another guy washing, or that's just me again. Can't really tell. Just a moment, I'm going to try and kill this tab. Ah, she gone. Anyway, what are we doing? Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. We're just going through this because I believe I did the entire page yesterday, or a week ago, I guess. Same deal, you know? Alright, we got a point with x and y, it's an I32. Mutable p is a point, x and y, but x equal, I don't think, yeah, that'll work. I don't see an issue, I don't see why that won't work. Yeah. That'll be 1 space 2. I think that'll work, sure. Am I wrong? Yeah, I'm incorrect. It doesn't compile. Why? That does not compile. What? Oh, yeah, that'll be 2 and 3. I'm a bit of an idiot, you see? I got it correct. That looks like it will compile. I see no issue with that. But I forgot that we added 1 into it. Yeah, I'm not the most intelligent creator. What's wrong with this, though, again? I wasn't really paying attention. Correct? This does compile, yeah. The output will be 2. Yeah. Again, I'm an idiot and can't do basic math. That's okay. We have computers for that, right, guys? Right, guys? But I got it correct in the way that really matters. This will compile, and this will compile. That's what, in the end, is the point of this. Yeah, so, well, I guess here, I should have remembered that this is by value. I did state that. You can look back at the VOD. But I forgot that by value. That is not by reference, and thus this won't actually work. Bit of a fool there. Anyway, I'm going to wait just a little bit for hopefully some people to come in. If you are in chat, you are watching, I'd love to hear from you to know I can start up. I was just finishing off the quiz from last time. I should have done it, but hey, you know. I'm going to wait until 10 minutes is through, at which point I'm just going to start reading. Hope y'all have had a good time. Hope y'all have been enjoying this wonderful book. We're We still have a lot to go. We are about a fourth through. A fourth through. Not terrible, you know. 1/4 through. Things are gonna get, especially at the end. Oh, I was gonna say at the end it's just gonna be like fixing some stuff up, but no, it looks like we just go straight in depth. I assume we'll know quite a lot about this and how Rust works around perhaps. Ah, here we go. Building a command line program. Yeah, around this point, I think that we'll know enough to be able to do some serious work in Rust. Well, perhaps there's a little bit more we'd have to learn. I don't think we are going to. I don't think smart pointers are going to be necessary, nor fearless concurrency, etc. Patterns and matching, I believe, will be just required to know. I've seen a lot of that stuff in Rust. Which is weird that it's that far in, but I guess they need a bit more of the information put between where we are and there. Either way, you know. Alright, we're continuing to go on. I'm just going to quickly go to Lammy Rust. Let me get up, look at it for a little bit, you know. Remind ourselves of the goal. This is why we do it. A link aggregator for 4. Yeah. It's mostly Rust, but it's a little bit of a ELPQ SQL. I've never heard of that before. Not what in the world is this? What is this? ELPQG SQL. I have no idea what this is. Procedural link. Oh, it's just Postgres. Yeah, okay. I haven't worked with that in like years. Strangely, I've been working with a lot of really old stuff recently. Just Oracle SQL. A lot of it. A little bit of MongoDB. Can't believe I haven't been touching Postgres a lot. A lot of people talk about it, a lot of people using it. I guess maybe it's starting to wane off. I haven't thought about it in a while, man. Curious how much I'll even recognize if I just randomly go into here. Let's go into the source. Just check some random trash out. Let's go to main. What's in here? Alright, we got clap. Well, hopefully we don't get the clap. That's strange, crit. What? Oh, hey, Silver Sorbet. Sorry, I'm just messing around. It's been 3 minutes since you put that into chat. I feel incredibly embarrassed. Sorry for that. I don't know what I was doing there. Hopefully you're still here and not just, sorry about that. It is good to see you again, Silver, though. I'm going to start in about a minute. We did go through another section of this while you were gone. I think you thought we were leaving. Sorry for that. We just went over a bit of a definition and instantiating structs. You seem to know your stuff, so I don't really know if you need to do a review of structs at all. But you can probably figure it out from what we're doing here. Sorry about that. Anyway, to confirm, I'm probably not going to be able to do the entire 2-hour stretch. Gonna stop around 8:30ish, maybe 8:40ish. Not doing the best right now. Did some shit to myself. Terrible idea. That sounds a lot worse than it is. Don't worry about it, man. Sorry. Gonna be a bit off today. Very tired. Did not sleep very much last night. But hey, I'm still gonna truck forward. You gotta do that in life, man. Okay, so I'm just gonna start reading this and going through it. Hopefully we see Keith. This is the second week in a row I've tried to get a hold of him outside of this and just could not. And I'm just gonna start though. An example program using structs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We'll start by using a single variable, then refactor the program until we're using structs instead. We'll make a new binary project. This is good. We're actually doing a little bit of work. A little bit of something. Alright. I believe we're at day 7 right now. We haven't done anything in a bit. Oh, wait. I forgot. I don't think we need to recursively destroy because we haven't actually done anything, have we? What am I doing? Once more, very tired. Don't really know what I'm doing. You? Hello? Now let's just CD into day 7. And let's create with a cargo. What is it again? There wasn't a generate thing, right? It's just cargo in there, right? I can't remember. Let's hope this is it. Nope, it's new. Cargo new. Cargo init is to initialize a crate. We haven't learned that yet. We're going to call this rectangles. Rectangle reckoning. Alright, let's go. We are going to have a main file. We already have this. Glad we're coding again. It's been a while since we've coded something in Rust. Let's just type this out. Why not? It should be snake case, apparently. No code actions available. I don't care, actually. It's just warning. We don't care about those. Okay, so we're going to start this out quite simply. We're going to let a width equal 30. We're going to let a height equal 50. That's supposed to be 30, not 50, or 20. We're then going to print a line. And the printed line will be quite simply the area of the rectangle where pixels. Alright. We have a function called area, which we will create soon. Taking in width and height 1. Pretty simple, and area is not going to be too hard. It's just going to be 1 times the other. This is why AI is slightly useful, because when you have it set up, it'll know exactly what you're doing. This is very simple. I really don't think that we need to type this entire thing out, to be honest. I don't think this has gained us any information. Again, they should just put it in return. Like, come on, how hard is that? That really doesn't hurt anything. Is this so bad? Is this so bad? Just return. Does that hurt anything? No, it really hasn't. Alright, I forgot to tell this that it returns something. Good reminder to myself. Gotta return. What is this? Okay, again. Once more, I am incredibly tired. Oh, yeah, you put a semicolon, it doesn't return the value. Of course it doesn't. Why would it? I think that's good enough. We typed in something correctly. Wow. We should be impressed with ourselves. Now run this program with cargo run. I just have an alias for CR, cargo run. What's that saying? Ah, it's 1,500. That's good to know. The area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters, and it's not clear in our program what the parameters are in our program that the parameters are related. It would be more readable and more manageable to group width and height together. We've already discussed one way we might do that in the tuple type section in chapter 3 by using tuples. Ah, we have rec1, which will equal a tuple with 30 and 50. Let's guess what next they're going to tell us. It's going to say, hey, this isn't very definable. Like, we don't know if the first one or the second one is, in fact, the width or height. This is quite useful when it's just a bunch of values that need to be added together, or it doesn't really matter where the value is. But in this situation, where we don't actually know, where we need to know one's height and one's width. Oops, forgot this. Now, y'all understand what I'm saying, even if I don't. What is a tuple type? Yep. Notice to define a tuple, it's just regular brackets. Good stuff, I believe that'll work. They call it dimensions, I called it rec1, or rec, but I think we understand. Right. In one way, this program is better. Tuples let us add a bit of structure, and we're now passing just one argument. But in another way, this version is less clear. Tuples don't name their elements, so we have to index each part of the tuple, making our calculation less obvious. Yep, it's less explicit. Just like when you fail to put in the word return here. It's less explicit. It doesn't tell you what's happening, and that's not a good thing. Mixing up the width and height wouldn't matter for the area calculation, but if we wanted to draw the rectangle on the screen, it would matter. We would have to keep in mind that width is the tuple index 0 and height is the tuple index 1. This would be even harder for someone else to figure out and keep in mind if they were to use our code, because we haven't conveyed the meaning of our data in our code. It's now easier to introduce errors. Refactoring with structs. Okay. So we're just going to add in a struct. We use struct to add more meaning by labeling the data. We can transform the tuple we're using into a struct with a name for the whole, as well as the parts, as shown in listing 510. We have a struct called rectangle. Struct calls rectangle has a width of type U32 and a height type U32. Next, we are just letting the rectangle equal a rectangle with a height with a width of 30. Okay. Okay. I'm going to have to fix that. That is poorly built. That's going to be incredibly annoying. And a height of 50. Put that there. We are now going to pass in a reference to rex1. This is going to expect a rect of type of reference, a rectangle. I'm going to return U32. This will be dot width. This will be dot height. Fantastic. I believe this will work. Let's just check. You have to put a comma after each element in the struct? Do you? Do you mean when initializing? Is that improper? I don't see it. Apparently not, because this compiles and works fine. Yeah, the only warning is stating that I named it incorrectly, which is fair. I mean, that might be proper Rust code. But I'm not seeing any issue or errors, even without the comma. I do prefer this way, though. This is much better, and it's one of the main reasons I hate JSON. JSON is a terrible thing. You can't just put a comma here, because what if I want to do that? What if I want just like 5 things? I agree with this. This makes it a lot easier, because if you want a different element down here, like height 2 or something like that, you can just copy it down. Not that hard to do. But in this case, in the case where there isn't one, it'll cause an error, and it's more difficult to put through. I agree with putting the comma at the end. This is a compiled language. It doesn't really matter if we have too much stuff. Yeah, that's a good point to just point out, because JSON, if you do put a comma at the end of a list, it'll error out. It'll break your thing, which is incredibly stupid. But yeah, that is a good thing to point out. Okay, yeah, this is just what we wrote. Compiles fine. Here we've defined a struct and named it rectangle. Inside of the curly brackets, we defined the fields as width and height, both of which have a type of U32. Then, in main, we created a particular instance of rectangle that has a width of 30 and a height of 50. Our area function is now defined with one parameter, which we've named rectangle, whose type is an immutable borrow of a struct rectangle instance. As mentioned in Chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retains its ownership and can continue to use rect1, which is the reason we use a reference in the function signature and where we call the function. The area function accesses the width and height fields of the rectangle instance. Note that accessing fields of a borrowed struct instance does not move the field's value, which is why you often see borrows of structs. Okay, it's going to be quite common. Our function signature for area now says exactly what we mean. Calculate the area of a rectangle using its width and height field. Okay. I'm sorry, what? Our function signature for area? What are you talking about? Our function signature doesn't say anything. Maybe function signature means something that I don't fully understand, I guess. I don't care. And gives descriptive names for the values rather than using a tuple index of values 0 and 1. This is a clear win for clarity. Adding useful functions with derived traits. It would be useful to be able to print an instance of a rectangle while we're debugging our program, and to see the values for all of its fields. Listing 5-11 tries using the printline macro, as we have used in previous chapters. This won't work. You can't just print out rect1. That makes sense? Yeah, we need to change this into something else. This is just a reference to the first field of the struct, I assume. When we compile this code, we get an error. With the core message rectangle, it does not implement standard format display. Okay, that is an interesting thing. The printline macro could do many The printline macro can do many kinds of formatting, and by default, the curly brackets tell printline to use formatting known as display. Output intended for direct end-user consumption. Oh, okay. The primitive types we've seen so far implement display by default, because there's only one way you'd want to show a 1 or any other primitive type to a user. But with structs, the way println should format the output is less clear, because there are more display possibilities. Do you want commas or not? Oh, okay. I don't care about that. Do you want to display the curly brackets? Should all the fields be shown? Due to this ambiguity, Rust doesn't try to guess what we want, and structs don't have a provided implementation of display. Use with println and the brackets placeholder. I don't know how to feel about that. Honestly, I do wish it would just print it out normally if we just put it in. But I guess this way it can force you to understand there are more ways to display it. Alright. If we continue reading the errors, we'll find this helpful note. Help! Oh, good! It just tells you how to actually do it. So it just forces you to understand the ways of formatting. Note, in format strings, you may be able to use : or : hashtag ? For pretty print. I like pretty print. Instead, let's try it. Okay. Let's just do this. I don't know why I did that. I could just comment it out pretty easily. Let's just print. We're going to print. That's correct. Here is what. Let's try pretty print. I like the idea of pretty print, because it says the word pretty, and I am a pretty man. I'm sure I messed something up. Wait. Oh, okay. Yeah, okay, yeah. So we do need to specifically derive debug in here. Consider annotating rectangle with derive debug. Okay, annotations. Are we going to learn a lot more about annotations? Right, compile the code with this change. Drat, we still get an error. Rectangle doesn't implement debug. That's not the error that I got. Yes, that is the error that I got. No, that's not the error that I got. I want to get that error. I'm gonna try without pretty print. Maybe that is why I got a different error. I mean, it's giving me the correct answer in here, so it doesn't really matter. I'd still get it. Am I doing this incorrectly? I really don't understand why. Oh my god, I'm a fool. Yeah, read the error and it'll help you out, man. Yeah, that's the correct error. But again, the compiler gives us a helpful note. It says, hey, use derive debug. On, is it the struct or is it the rectangle itself? It is the struct. Good stuff. I don't understand why. Why is this a thing? If we use it like that, why wouldn't this be normal? Oh, we just have a help here too, anyway, so. Is there a... No, whatever. I wonder if there was a code action. Is there an issue? Yep, these are never red. That's their code. Ah, there we go. Yeah, that's perfectly fine. That works how I'd want it to work. Let's try with pretty. Is that just going to give us new lines? I hope that gives us new lines. Yes! Gives us new lines. I like that. Okay, Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. That is good, because leaking debug information is not a good thing and can get you fired. To do that, we add the outer attribute, derive debug, just before the struct definition. Alright, so somebody like me can come in and write a CI/CD thing that just strips that out of the entire program. If errors are caused, well, that's a good thing. The Rust will actually show those errors, and it won't just compile and allow us to fail when we push it up to main. Just before the struct definition. Derive, debug. Good stuff. Now, when we run the program, we won't get any errors, and we'll see the following output. Okay, nice. It's not the prettiest output, but it shows the values of all fields for this instance, which would definitely help during debugging. When we have larger structs, it's useful to have output that's a bit easier to read. In those cases, we use pretty formatting instead of regular formatting in the print line string. In this example, using this, we'll put out this output. It'll just give us new lines. Another way to print out a value using the debug format is with the dbg macro, which takes ownership of an expression as opposed to printline, which takes a reference, prints the file and line number of where that debug call macro call occurs in your code, along with the resultant value of that expression, and returns ownership of the value. Note, calling the debug macro to the standard prints to the standard error console stream, standard error, as opposed to printline, which posts it to standard out. We'll talk more about standard error and standard output in writing error messages to standard error instead of standard output in section of chapter 12. That's a good thing to know. Here's an example where we're interested in the values that get assigned to the width field as well as the value of the whole struct in rectangle 1. Okay. That's interesting. So we just have a let? Yeah, so it does pass it out. Debug does pass it out. That's good to know. Oops. DBG? Do we have to use DBG, or is that just there always? Good. It's just there always, I guess. Kind of weird that we have to explicitly add in the derive, but we don't have to explicitly add in the ability to debug. I suppose printline, we don't have to put in some form of IO stream. We don't have to bring that in. That's just there by default, so I guess that's fine. Now we are going to just debug. Debug. A reference to rect1. I believe that's fine. Yep, and it tells us the line where it is. What did I just do? Sorry about that. I guess I just killed it. I don't know what I did there. Sorry about that. Right. Do I have a debugger? Well, I haven't compiled the thing yet, have I? I do seem to have a debugger. Good to hear. but I haven't built it, so I'm not going to mess around with the debugger. You could just use a debugger in this case, but we are not currently. You can see the first bit of output came from source main.rs on line 10, where we're debugging the expression 30 times scale, and its resultant value is 60. The debug formatting implemented for integers is to print only their value. The debug call on line 14 of source main.rs outputs the value of rec1, which is the rectangle struct. This output uses the pretty debug formatting of rectangle type. The debug macro can be really helpful when you're trying to figure out what your code is doing. Do we need the derive for debug? Do we need that? Yes. Yes, we do. Okay, that makes sense. I like that you can just put it in line here. Like, you can put any expression into debug, it'll output it, and then pass it back. A lot of the time, you'll have these weird situations where you have a line where you like create the rectangle and then you just try and output it outside of rectangle, and it won't be perfect because of some weird situation in the code. I guess with the Rust, that'll be a lot lesser, but I'm glad that you can just put it exactly where you need. Because perhaps you just want to test one part of the expression. You want width not only to be 30 times scale, but also divided by 2. I'm assuming that'll work perfectly, right? I'm kind of curious. Will that work? Well, that's not going to work. Yes, that'll work. So you can have an entire complex chain of information of a code and just test one bit, which you're unsure if it actually does the thing you want it to do. That's pretty good to know. I'm going to write a mapping to surround the area with the debug piece. That's going to be a thing I'm going to write. It's going to be really easy to do. But yeah, that's pretty cool. I really like that. You can just put this anywhere. Huh. I can't express how much I like that. That is really cool. Here's what the output looks like. It tells us where and what. Oh, it also tells us the, I didn't notice that. Yeah, it also tells us the math within. That's cool. I'd like to read what the macro does. Macro rules? I'll read that on my own. Apologies. We can see the first bit of output came from source main.rs line 10, where we're debugging the expression, and its resultant value is 60. The debug formatting yep, we've read that. Apologies. In addition to the debug trait, Rust has provided a number of traits for us to use with the derive attribute that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We'll cover how to implement those traits with custom behavior, as well as how to create our own traits in Chapter 10. There are also many attributes other than derive. For other information, see the attributes section of the Rust reference. Area function is very specific. It only computes the area of rectangle. It would be more helpful to tie this behavior more closely to a rectangle struct, because it won't work with any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method, defined on our rectangle type. And now we have a quiz. This speaks as if we're supposed to see something. Method syntax. Yeah, that's just going to give us that after this quiz. Let's read the quiz. Determine whether the program will pass the compiler. If it passes, tell us what it does. Alright, we got a rectangle, width and height, U32. We got main, which is rectangle 1, taking 30 and 50 for our height and width. Let A equal area, rect 1. This passes back U32, takes in a rectangle time. Yep, we've seen that before. Front line, rect.width, rect.height, A. Right, so the issue here is that we are not passing in by reference, meaning ownership is consumed by area. I don't think this does compile. I'm just gonna check, man. I'm just gonna check. Why not? Do you think, Silver, do you think that this will compile without the reference? I mean, it may. It is consumed, but we're not using rect afterwards, are we? No, we are using rect afterwards, so perhaps it won't. Consider borrowing here. Expected reference to a rectangle? Yeah, because we state that. Value moved here? Yep. Warning, unused variable. If this is intentional, prefix it with an underscore. Apparently that's fine. Value moved here. Yes. That is a warning. That is a help. Now if we use it, is that gonna... you know what, we'll see afterwards. We'll see when this tells us we're wrong. I don't think this will compile. Which statement best describes the difference between display and debug traits? Display is for printing values to the console, while debug is for viewing values in a debugger. Incorrect. Display cannot be implemented on structs, while debug can be implemented for structs. There is no difference? There is a difference. Display is for Display is for presenting value to an end user, while debug is for developers' internal use. I believe that to be correct. Okay. Yep, that is correct. This does not compile because we are not passing by reference and we are utilizing it afterwards. Ownership is consumed by area. Good to know. Alright, method syntax. Here we go. We can finally do OOP, object-oriented programming. Methods are similar to functions. We declare them with the function keyword and a name. They can have parameters and a return value, and they contain some code run when the method is called from somewhere else. Unlike functions, methods are defined within the context of a struct for an enum or a trait object, which we'll cover in chapter 6 or 17 respectively. And their first parameter is always self, which represents the instance of the struct the method is being called on. Defining methods. Let's change the area function that has a rectangle instance as a parameter, and instead make an area method defined on the rectangle struct, as shown in 5.13. Right, so we have a struct. I'm just going to create a new thing here. No, I'm not. Yeah. Whatever. Alright, so we're going to take this, and we're going to move it up. We are going to call it. Now we're going to surround it with implement MPL rectangle. We're going to move this in. Function area. We are going to have a reference to self. And instead of rect, it will be self. Fantastic. I'm going to just assume. I've not read this, but that's going to be something like rect1 dot area. Oh, no. It'll probably be something like that, right? Oh, well, is this reference? I don't know what to do, man. Is this part of the reference? What is wrong with that? Yeah, that's fine. That's what I did first. Okay, whatever, man. Right. The only difference here is that we have a print line, which will take an A. There we go, that'll work fine. Well, we have some debug messages, but what are we going to do about those? The area is 3,000. Oh, we've also done that. We forgot to clean up some of the stuff, but I believe we've done this fine. That seems to be what we're doing. Yep, so there we go. We have object-oriented programming. The ability to do so if we so wish. To define the function within the context of a rectangle, we start an implementation block for a rectangle. Everything within this IMPL block will be associated with the rectangle type. Then we move the area function within the implement curly braces and change the first, and in this case only, parameter to be self in the signature and everything within the body. In the signature and everything within the body. In main, where we call the area function and pass rect1 as an argument, we can instead use method syntax to call the area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any argument. Good stuff. In the signature for area, we use reference self instead of rectangle, reference rectangle. The reference self is actually short for self of type reference self. Good. Within an implement block, the type self is an alias for the type that the IMPL block is for. Methods must have a parameter named self of type self for the first parameter. So Rust lets you abbreviate this with only the name self in the first parameter spot. Note that we still need to use the reference in front of self shorthand to indicate that this method borrows the self instance, just as we did for rectangle reference rectangle. Methods can take ownership of self, borrow self immutably, as we've done here, or borrow self mutably, just as they can any other parameter. That's good to know. I quite like that. I really like this syntax. Like, I don't love the entire function pointer thing that you see in other languages when you try and do this type of stuff. It can get quite confusing. We chose self here for the same reason we use reference rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we've called the method on, as part of what the method does, we'd use mute self, reference mute self, as the first parameter. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else, and you want to prevent the caller from using the original instance after transformation. Usually it would also return a new instance. Perhaps if the function resizes the original, destroying the original necessarily so. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self every method signature, is for organization. We've put all the things we can do with an instance of a type in one impl block, rather than making future users of our code search for capabilities of rectangle in various places in the library we provide. Note that we can choose to give a method the same name as one of the struct's fields. For example, we can define a method on rectangle that is also named width. Here we go. We have implementation, rectangle, function width, self, type bool, checks if self.width is over 0. The rectangle has a non-zero width. Yep, that's just checking if it is non-zero. Here, we're choosing to make the width method return true. if the value in the instances with field is greater than 0, and false if the value is 0. You can use a field within a method of the same name for any purpose. In main, in main, when we follow rect1.with with parentheses, Rust knows that we mean the method with. When we don't use parentheses, Rust knows that we mean the field with. Often, but not always, when we give a method the same name as a field we want it only to return the value in the field and do nothing. Methods like this are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, the method public, and thus enabled read-only access to that field as part of the type's public API. We'll discuss that public and we will discuss what private and public are, how to designate a field or method as public or private in Chapter 7. Methods with more parameters. Let's practice using methods by implementing a second method on the rectangle struct. This time, we want an instance of a rectangle to take another instance of a rectangle and return true if the second rectangle can completely fit within itself. The first rectangle. Otherwise, it should return false. That is, once we've defined the can-hold method, we want to be able to write the program shown in listing 114. Are you asking me to write this myself? I'm glad. This is the first time they've taken us and just let us do something. Right. Are we allowed to just put two implements in the same area? Is that the function name? Is this what you want? Sorry, is this what you want? And underscore hold. Yep. So if we have 3 rectangles, we can check if that will work. Yep. Function can hold, which will be this. Adding a parameter list, which will be a reference rectangle. Of type rectangle. Oh, I'm an idiot. Yep. We want reference rectangle. Never used, is empty. Yep. Alright, so apparently this is fine. Okay. Let's just get rid of that error by copying this in. This will just be what we're doing. So let's just paste it in. No method named canHole can be found for struct rectangle in this current scope. Okay, so can we not do this? Can we not just put it in here? The candidate is defined as an impl for the type rectangle. Yes. Let's just return 1. Or 2, sure. Oh yeah, we're returning, so we're going to return a boolean. So boolean will have to be 1. Let's always return true. Expected bool because of the return type. Yeah. Fine. Apparently that's an integer. That's, well, I guess that makes. True. Return true. Alright, I think what that means is that we're not allowed to put this in here. Is that incorrect? What is wrong with this? Oh my god, you fool. Self. You have to put in self? What is the problem? Well, that's fine. Okay. Is this fine? Yeah, that's fine. Okay, I believe that'll work. We'll see. Fields width and height are never read. Correct? Okay, okay. So we're just going to get can hold. Let's use guard syntax. Can fit. Equal, let's say it's false by default. Alright, fine. Alright, so if... Wait, what am I doing? I am incredibly tired. I am so sorry, Silver. You're going to be yelling at this screen, acknowledging the fact that I'm a bit of a fool here. You've already got it yourself. You've already got it done yourself, I can imagine. But I am a bit of a fool, and am in fact extremely tired. Here is where we understand how much of a dumbass I am. Right, if self dot width. You already have it? Yeah. Equals rect1 dot width. I don't need... Yeah, I don't need that, do I? Look, man, you code all day, and then you come home and you code a little bit more, and eventually you're going to get a bit tired of it. Well, that's not how you spell height. That's also not how you spell height. Okay, is that okay? Unnecessary parentheses. Yeah. Yep. Can't compare reference U32 with U32. Why? What? Yep. Why did I do that? Right. Redirection. Yep. Again, I'm tired? That's fine. Wow, how dumb was that? First off, I tried to get a reference. Okay. Okay. Yeah. Yeah. I think that's fine, right? No. Ah. Look. Look. I am so sorry. I hope your hair is fine. I hope your hair is fine. This is probably doesn't work, but I don't care. I think I've got it down pat. That probably works. Yeah, that's the expected output. I put equal equals instead of... Okay. That was a comedy of errors, but I'm not laughing. Ignore the laugh. I am so sorry, Silver. I hope you weren't watching that. I hope you looked away at that horror show. I am so sorry. That was such a waste of time. Oh no. Why is there an if? Why is there an if? Oh my god. Why is there an if? You watched everything. Oh no. Oh no. Oh, I could blame the lack of sleep, but I am an idiot. That might be the issue. Yeah. Yeah. Ah, okay. Can we? Do we need this? Well, of course we do, yeah. Shame. We know we want to define a method, so it will be within implement rectangle block. This method name will be can hold, and I'll take an immutable borrow of another rectangle as a parameter. We can tell what the type of the parameter will be by looking at the code that calls the method recta1.canhold reference rect2. Passes in reference rect2. This is an immutable borrow to rect2, an instance of rectangle. This makes sense because we only need to read rect2 rather than write, which would mean that we don't need a mutable borrow. We want main to retain ownership of rect2, so we can use it again after calling canhold. The return value of canhold will be a boolean, and the implementation will check whether the width and height of self are greater than the width and height of the other rectangle, respectively. Let's add the new canhold method to the impl block in listing 513, shown in here. Right. Yep. They call it other. That's actually that's good. Yeah, so one liner, you moron. A, what? Oh god. A, I tried guard syntax on a boolean. B, I tried an if on a boolean check. Oh my god. And C, I continually failed. Like, just equals was not the correct thing. I tried reference. I tried to get a reference of it, then I tried to dereference what would be just a value. Oh my god, am I an idiot? Luckily, I'm hiding my face. I would fire me if I found that on the internet. God. We run this code in the main function, listing 514 will get a desired output. Methods can take multiple parameters that we add to the signature after the self parameter. And those parameters work just like the parameters in the function. I'm glad I could entertain you, Silver. Oh god. Associated functions. All functions defined within an impl block are called associated functions because they're associated with a type named after the impl. We can define associated functions as functions that don't have self. We can define associated functions as functions that don't have self as their first parameter and thus are not methods, because they don't need an instance of the type to work with. We've already used one function like this, the string from function that's defined on the string type. Associated functions aren't methods. Associated functions that aren't methods are often used for constructors that will return a new instance of the struct. These are often called new, but new isn't a special name and isn't built into the language. For example, you could choose to provide an associated function named square that would have one dimension parameter and use that as both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. Ample rectangle with a function square of size. Yep. Self, width, and height is both sides. Oh, okay. Returning self. And then, okay, yeah, okay. I like that, that's fine. Makes constructors easier to make. The self keyword in the return type And in the body of the function are aliases for the type that appears after the impl keyword, which in this case is rectangle. To call this associative function, we use the : syntax from the struct name. Let square equal rectangle : square 3. Isn't it? Sorry. Yeah, that is an example. The function is namespaced by the struct. The : syntax is used for both associative functions and namespaces created by modules. We'll discuss modules in Chapter 7. I'm excited for that one. Multiple impl blocks. Each struct is allowed to have multiple impl blocks. For example, listing 5-15 is equivalent to the code shown in 5-16, which has each method in its own impl block. Okay, so yeah, that's good. If we could probably bring in 2 modules. One module that includes more pieces for the original struct, I guess. There's no reason to separate these methods into multiple impl blocks here, but this is valid syntax. We'll see a case in which multiple impl blocks are useful in Chapter 10, where we discuss generic types and traits. Method calls are syntactic sugar for function calls. Using the concepts we've discussed so far, we can now see how method calls are syntactic sugar for function calls. For example, let's say we have a rectangle struct with an area method and a setWidth method. Yep. And let's say we have a rectangle R. Then the methods calls r.area and r.setWidth2 are equivalent to this. Let mutable r, rectangle, of these types. Let area1 equal r.area, and let area2 equal rectangle : area, passing in r. Okay, yeah, because self. That's good that that's possible. So this will just be the first parameter, which will be called self, and it'll work perfectly fine. Yeah, so that's just syntactical sugar. Good to know. Assert equal, it'll be the same thing. Yep. The method call r.area becomes rectangle : area, reference r. Function name is the associated function, rectangle : area. Function argument is the self parameter. Rust automatically inserts the borrowing operator. Yep. Note that if you are familiar with C or C++, you are used to 2 different syntaxes for the method calls, r.area and r.arrow area. Rust does not have an equivalent to the arrow operator. Rust will automatically reference and dereference the method receiver when you use the dot operator. Okay, yeah, I did try that. At one point, didn't do anything. I'll let you know that's not here. The method call r.setWidth2 similarly becomes rectangle : set_width of immutable reference r with a mutable reference r and bringing in 2. This method expects a mutable reference to self. The first argument is a mutable borrow to r. The second argument is exactly the same, the number 2. As we described in Chapter 4, .3, dereferencing a pointer accesses its data. Rust will insert as many references and dereferences as needed to make the types match up for the self parameter. For example, here are 2 equivalent calls to area for a mutable reference to a boxed rectangle. We have r, which is a new boxed rectangle of width 1, height 2. Area 1 equals r.area. Area 2 equals rectangle : area. Reference to the dereference of a dereferenced r. Assert equal area 1, area 2 will be correct. That's true. Rust will add 2 dereferences, once for the mutable reference, once for the box, and then 1 immutable borrow because area expects reference rectangle. Note that this is also a situation where a mutable reference is downgraded into a shared reference, like we discussed in 4.2. Conversely, it would not be allowed to call set_width on a value of type reference rectangle or reference box. of type rectangle. Let's start the quiz and show how terrible I have been. I have not been paying a lot of attention, I don't believe. What is the keyword for constructor functions in Rust? None of the above. There's no keyword for construction functions in Rust. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. Okay. Sorry, we've read that so much, I don't know why I didn't just get it. We have a struct, pointer, i32, function main. Sorry, struct is called point. Let p equal point, 1, 2, implement point, function x, self, i32, self.0. Can an implementation be inside main? I don't see why not. Why would it not be able to be done like that? That should be fine. Does compile, I believe that'll be fine. It'll output 1. I don't see any issue with that. Alright, we got self. We have self, it says, hey, we're pushing out an i32. This is of a type i32. That's correctly made. This is a borrow, so it's not assuming ownership. Just returning self.0. I think that's fine, yeah. We got 1 of 2. Why doesn't it compile? Why does this not compile? Methods. Oh my god! This is what happens when you rush through. We're implementing on P and not on point. That's a good point. No, we cannot. Thank you, Magel. That is correct. You saw that? I did not. I just assumed that this was doing it correctly, but no. That's a good point, though. Like, in JavaScript, the most beautiful language, we absolutely could do something similar to this. We could just take P and then implement something on that. But not here. Not here. By the way, welcome, Magel. Glad you could make it. It's been a while. Sorry I've not been more active in the community. That is a shame, though. I really wish you could. I really do wish you could do that. I guess I'm used to JavaScript. Don't really see too much use for it in No, I see a lot of use for it. I like making things that are entirely meaningless. Sorry for being late. Daylight savings shifted the time. I am sorry. Yeah. Sorry about that, Magel. And this is going to be a bit of a shorter stream. I can't really continue too much further. Gonna likely get to the bottom of this and then peace out. It's good to see, though. Is the current time fine for you? Like, will that be fine going forward, Magel? Or should I change it around myself? I could probably next week start an hour later if needed. So this is good. Glad to hear. Methods cannot be implemented for types. Yep. Okay, let's continue on. Methods and ownership. Like we discussed in Chapter 4.2, references and borrowing, methods must be called on structs that have the necessary permissions. As a running example, we will use these 3 methods that take self, a reference to self, a mutable reference to self, and self, respectively. Rectangle, function area, self, reference, u32. We have a set underscore width, reference to a mutable self, and a width of type u32. Self.width equals width. That's perfectly fine. Max takes in self itself, other rectangle, outputs rectangle. Creates a new rectangle with width dot self.width dot max other dot width. Okay, so yeah, so this takes in a rectangle, and then it will create a new rectangle that is the largest possible rectangle, utilizing the width and height of both rectangles. Okay. Reads and writes with self and mute self. This will also destroy the original. Okay. If we make an owned rectangle with let rect equal rectangle, then rect has read and ownership permissions. What? Then rect has read and ownership permissions. Apologies. With those permissions, it is permissible to call the area and max method. Yep, makes sense. We have a rectangle with width and height of 0, line rect, which has read that area, perfectly fine. Let other rect equal rectangle with height 1, max rect equal rect.max other rect, and create a new rectangle and I believe consume ownership and destroy. I believe that'll consume ownership and destroy. Well, consume ownership. It'll be inaccessible ownership of rect. Is that incorrect? However, if we try to call set_width, we are missing the right permission because it's not immutable. Yep. Rest will reject this program with the corresponding error. Cannot borrow rect as mutable, as it is not declared as mutable. Consider declaring it as mutable. Cannot borrow as mutable. Yep. We will get a similar error if we try to call setWidth on an immutable reference to a rectangle, even if the underlying rectangle is mutable. Right, we got a mutable rec. We have rec.setWidth1. This is okay. We have a reference. Well, yeah, I mean, this is just the basic stuff. This is mutability. We learned this in chapter 4 or something. I don't see how this would reasonably... I guess this is just a bit of a refresher. Just to show you. I don't really know, man. Right, of course, this is going to fail because we have a reference that's not mutable. Rect_ref. Read but not write. SetWidth does not work. Moves with self. Calling a method that expects self will move the input struct unless the struct implements copy. For example, we cannot use a rectangle after passing it to max. Correct. Rect equals rectangle. We have height in 0. Yep, other rec. Correct. We have max rec. Passing in the other rect. Then we try and print out rect. Does not work. To call rect, we get this error. Borrow a moved value rect. Move occurs because rect has type rectangle, which does not implement the copy trait. Rect moved due to this method call. Rect.max other rect. Line rect area. Value borrowed here after move. A similar situation arises if we try to call a self method on a reference. For instance, say we try to make a method set_max that assigns self the output of self.max. Function, immutable reference self, other rectangle. We take the value of self equals self.max other. Okay. This does not have ownership. Self does not have ownership, of course. Then we can see that self is missing the ownership permission in the operation self.max. Rust therefore rejects this program with the following error. Cannot move out of reference self, which is behind a mutable reference. Reference self equals self.max other. Reference self moved due to this method call. Move occurs because dereference, not reference, I keep saying that, has type rectangle, which does not implement the copy trait. Oh. I don't know what I just did. I guess I just moved down accidentally. You might wonder, oh, this is the same kind of error we discussed in 4.3, copying versus moving out of a collection. You might wonder, why does it matter if we move out of reference self? In fact, for the case of rectangle, it actually is safe to move out of reference self. Dereference self, apologies. Dereference self. Even though Rust doesn't let you do it. For example, if we simulate a program that calls the rejected set_max, you can see how nothing unsafe occurs, correct? Implement rectangle. Function set_max is immutable self, other rectangle. Let max equal. I believe that we've just done this. That's just the regular thing that we've done before. Let mutable rectangle equal a rectangle, and the other rect is the rectangle. Rect.set_max other rect. We have location 1, we have a rectangle and other rect. We have these right here. Location 2 is within here. we move this from rectangle, colon set to max. We move it into main. What? Right, we have self. We have immutable reference to rect in main. We are setting self, which is the new rectangle created from other. Create it to a max. That is gone, and we are moving self. What? Yeah, I guess so. Self just points to rect. My god, I'm sorry, I was reading ahead. Right, self just points to the rectangle here, and that's all it's trying to say. Other is gone. Max is the new thing, which is max. Other is no longer utilized, and thus is dropped out of memory. And now at level 3, location 3, rect.set to other max. Rect is now just a reference to this max. So we've taken self, which simply points to rect, and we are replacing this original rectangle with max, which is a new rectangle here, meaning in the end, we just have this new rectangle in main. That's fine. There's no issue with that. The reason it's safe to move out of dereference self is because rectangle does not own any heap data. In fact, we can actually get Rust to compile set to max by simply adding derive, copy, clone, the definition of rectangle. Oh, there we go, back to the derived pieces. That's quite good. Notice that, unlike before, self.max other no longer requires the ownership permission on self. Yeah, because it's just copying the value, or other. Remember that self.max other desugars to rectangle max dereference self other. The dereference self does not require ownership over dereference self. Rectangle is copyable. Correct. You might wonder, why does Rust automatically derive copy for rectangle? Why doesn't it automatically derive copy for rectangle? Rust does not auto-derive copy for stability across API changes. Imagine that the author of the rectangle type decided to add a name:*string field, and all client code that relies on rectangle being copy would suddenly get rejected by the compiler. To avoid that issue, name:*string because string doesn't implement the copy type. To avoid that issue, API authors must explicitly add derive copy to indicate they expect their struct to always be copy. To better understand the issue, let's run a simulation. Say we added name:*string to rectangle. What would happen if Rust allowed set to max to compile? Right? So we have the regular thing here. We have location 1, we have an implementation of a rectangle function set to max. We have a rectangle being created here and here, calling it here. All right, we go in, let max equals self.max other. Location 1, we have a rectangle, width 9, height 9, and name being pointed to some heap data. Fantastic. We also have a rectangle, self, pointing to the original rectangle. We have within rectangle colon set to max, self, which is pointing directly here, and other, which is a rectangle. Apologies, you can't see it through my fat face. With width 16 and height 16, and a name pointing to heap data. At location 2, which is after we have set max, which creates a new rectangle with the max width and height between the two, we now drop reference self. Before that, location 2 is at the end of this. Location 1 is beforehand, location 2 is afterwards, which simply shows that we have max, which is a new rectangle with a name that points to the heap data of max, and self pointing here. Name is dead. Name is dead. Name no longer points to heap data. Why? When did that get moved? When did that get changed at all? I really don't understand when that got changed. I'll admit, I actually just straight out don't understand why that dropped name. Well, that's no longer pointing to heap data. I'm guessing does it consume ownership of the name, and then once max is over, it drops it? I guess we'll get... fair enough. Sorry, Magel. I guess I'll just continue along. Undefined behavior, if pointer is used after pointer is freed. Right, yep. In this program, we call set to max with two rectangles R1 and R2.self. Sorry, with two rectangles... Self is a mutable reference to R1. Other is a move R2. Yeah, okay. Yeah, whatever, man. I'll just read on. The max method consumes ownership of both rectangles. Okay, sure. I mean, I could have probably figured that out if we had the max method here. We don't. Alright, it's above, I guess. Sure, that is why. That is why. Since it consumes ownership of both rectangles when it returns. When it returns, the string will be destroyed, and we'll be pointing to new heap allocated memory. Rust deallocates both strings R1 and R2 in the heap. Notice the problem. At the location L2, dereference self is supposed to be readable and writable. However, dereference self.name, actually R1.name, has been deallocated. Therefore, when we do dereference self equals max, we encounter undefined behavior. When we overwrite dereference self, Rust will implicitly drop the data previously in dereference self. To make that behavior explicit, we have added drop dereference self. After calling drop dereference self, Rust attempts to free dereference self.name for a second time. That's a double free. So remember, when we see an error like cannot move out of dereference self, it's usually because you're trying to call a self method on a reference, like reference self or a mutable reference of self. Rust is protecting you from a double free. Fair enough. Summary. Structs let you create a custom type that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. In an implement block, you can define functions that are associated with your type, and methods are a kind of associative function that let you specify the behavior that instances of your struct have. But structs aren't the only way you can create custom types. Let's turn to Rust's enum feature to add another tool to your toolbox. That'll be next week, I guess. We'll go on to enum. Good stuff. Let's finish this quiz. Say you have a variable v of type mutable reference to a vector of type i32s, and you want to call the length method with the following signature. Function len, reference self, returning a usize. If you compile the expression v.length, which of the following statements best describe what happens? You try to compile the expression v.ln, len. What? It does not compile because a mutable reference to vec i32 is not the same as a mutable vector of i32. What? Again, I spoke about this at the start of this. Magel, you didn't hear. I am incredibly tired. I may just not fully understand. So you have a variable v of type mutable reference to a vector of i32, and you want to call the length method with the following signature. You try and compile v.length. Which of the following statements best describe what's happened? Yeah, that's not true because this is implemented on the type. Yeah, so I get what it's trying to say, I think. Thank you, Magel. Okay, so I believe this is incorrect because you can do a mutable reference to a vec32 and still access members of a vec32. does not compile. V is not explicitly dereferenced. I don't think it needs to be. Maybe not. It compiles because the mutable reference is implicitly reborrowed as a reference. It compiles because reference self can take any type of reference. Unless anybody else is going to say anything, I'm just going to go with this one. It compiles because the mutable reference is implicitly reborrowed as a... Actually, no. It compiles because self can take any kind of reference, I believe. Yeah, my gut does say 4 as well. I don't believe I fully understand either, to be honest. Right, let's just go with that. Consider the two methods that increment a field of a struct. Which style would be more idiomatic for Rust? We have a point, I32, implement point, function increment volume 1, takes in a mutable self, self.0 plus equals 1. Or do we want a mutable reference to self? Okay, yeah, I believe the mutable reference to self would make more sense. Obviously, because this consumes ownership. Wouldn't that just... That consumes ownership, meaning that you couldn't actually use whatever you had there, and it also doesn't return anything since there's a semicolon here, so this is the only one that'll work. I don't know what it means by idiomatic, because the first one I don't think will work. Will it? No, I really don't think it will. Oh, whatever. You're not convinced it won't work? But you believe me. Well, I guess we'll see. I could be wrong. I very well could be wrong, honestly. I would love to be proven wrong. Well, sorry, we'll read that soon. Determine whether the program will pass the compiler. I think it is the most idiomatic either way. I don't think it'll compile, but I could very well be wrong, honestly. If I am, then I really don't understand ownership, and I gotta reread that. If it passes, write the output. Right. We have incr x, takes an immutable reference to self. Sorry, takes a mutable reference to self, self.0 plus equals 1. Point is a tuple, or an unnamed struct, I32. That looks fine. I don't see any issue here. I really don't see any issue here. Alright, let mut p equal 0.00, p dot increment x. Yeah, I think that does compile. I don't see any issue. We have mutable p is a point of type 0 and 0. Point takes an I32 and an I32. The function takes an immutable reference to self. That just increments self.0, which is mutable. I think that's fine. Pretty straightforward, and that will equal 1. Determine whether the program will pass the compiler. Point is x and y. Point, get x, mutable reference to self. Outputs a mutable I32. Colon mutable. Yeah. Yeah, okay, yeah. Self.x brings in self.x, a mutable reference to self.x. I think that's fine. Let mutable p equal point. Yep, creating the point. Let x equal p dot get x. That's not mutable. Or I guess it would be implicitly made mutable. If it's implicitly made mutable, then that's fine. Then dereferencing x plus equals 1. Current line dereferencing x and p dot y. Right. This doesn't consume ownership. This is simply a borrow, a mutable borrow. and it's not used after that, so I don't think that's fine. That's an issue. p.y. Also, separately, we don't actually... Oh, yeah. I mean, that would have a readable no matter what, but... Yeah, so we're using y, so that's even able to be mutated. But I don't see any issue with this either. See you later, Silver. Have a good week. Thank you for dealing with my stuff. My shit, Oh, you weren't here, Megal. I did terribly. Please don't look at the VOD. Or do if you have hair to spare. But thank you for being here, Silver. Have a great week. I think this will compile. I don't see any issue. Right, we got 2 of 4 correct. You're unclear on line 14? Yeah. Okay, so I did get this incorrect. It compiles because reference self can take any kind of reference. Okay. I thought that's what I clicked. Oh, that is what I clicked, and that's wrong. That is incorrect. Okay. That is correct. It is Inc 2. This is also correct. This does not compile. See the correct answers. This does not compile because get_x mutably borrows all of p. Yes, it does. I see. Okay. Program cannot use p in any way until x is no longer used. Therefore, reading x and p.y in the same line is an ownership error. I see. Yeah. Okay, so this is not something that was explicitly stated, but yeah. A mutable reference to self is a mutable borrow of the entirety of p, not just p.x. It cannot know what you're mutating. Sorry, what you are borrowing in the end. Yep. Yeah, that would have been perfectly fine, but the usage of p.y was the issue here. That's what made it break. So you do have to be careful. If you call a function which returns a mutable reference to something, it must either A, just take in p.x as a parameter, or B, you are borrowing the entirety of p for that period of time. Okay. Makes sense. The second one, yeah, so the incr1 method is not idiomatic because it consumes ownership of point. This means after calling p.incrv1, p would be unusable, which is probably not intended for the method. That's what I was saying. Yeah, so I was correct. This will not work. Okay, this was incorrect. The correct thing is it compiles because... Oh, well, yeah, it would compile. Sorry, did I say it wouldn't compile? Of course it would compile, but it wouldn't do much. No, it would be entirely useless. It wouldn't do anything. It doesn't return anything, and if you tried to use p afterwards, it would just kill it. Nah. Alright, so here, it compiles because the mutable reference is implicitly borrowed as a reference. Context. The expression v.lang, these sugars, vec, line, these sugars 2, a reference to the dereference v, which is a valid reborrow of v. So this expression compiles. Cannot, however, pass v directly into vec, length, since self specifically refers to an immutable reference. Okay. I'm gonna have to reread that, honestly. Alright, well, sad you couldn't have joined the bit earlier. Glad to have had you for the bit we did. But I am going to have to end at this point. I'm glad to have seen you again, though, Megal. It's been a while. Seriously, this is quite fun. I am really quite enjoying this. This chapter had a lot of actual building of code. I would really suggest looking back at it at your own. All this code was written during the entire thing. But I'm going to thank you once more and again, Megal, for joining us. But I am going to end at this point. Have an excellent day, and I'll talk to you later.